Hello everyone. In last lecture we have discussed theory of ballistic galvanometer. In today's lecture I am going to discuss current sensitivity, charge sensitivity and voltage sensitivity. Before going to study these three concepts, I would like to recall few of the things we have already discussed while studying theory of ballistic galvanometer. Okay, the first equation is I is equals to C divided by N B A into theta. This is the one of the equation we have already discussed in theory of ballistic galvanometer. Here I is current, C is restoring couple per unit twist, and N is number of turns, B is the magnetic field, A is area of cross section, and theta is the amount of deflection produced. And one more equation is Q is equals to T divided by 2 pi into C divided by N into B into A into theta, where Q is the amount of charge which flows through copper wire, and T is the time period, C is the couple produced per unit twist, and N is the number of turns, B is the magnetic field, A is the area of cross section, and theta is the deflection. For next discussion we are going to use these two equations. Okay, now let us see the first type, that is current sensitivity. Here current sensitivity can be defined as the angle of deflection per unit current flowing through it. Okay, let us try to explain current sensitivity by using the previous equation we have just now discussed, that is I is equals to C divided by N into B A into theta. Here C divided by N into B into A is constant, so I am going to replace this entire term by K, that is I is equals to K into theta, where K is equals to C divided by N into B into A, where couple produced per unit twist and number of turns, magnetic field, area of cross section all are constant, so we have replaced these entire terms by K. Here K is the constant for given galvanometer and it is called the current reduction factor of the galvanometer. Here K is the current reduction factor. Okay, now I am going to rearrange these terms, that is theta divided by I is equals to 1 over K. Here we define current sensitivity that the angle of deflection produced per unit current which is flowing in copper wire is nothing but the current sensitivity, or in other words we define current sensitivity that current sensitivity is reciprocal of ballistic constant, that is 1 over K. It is the reciprocal of ballistic constant. Okay, what is current sensitivity? Current sensitivity, it is simple, it is the amount of deflection produced per unit current. Okay, now here I will try to explain this current sensitivity by using experimental arrangement of ballistic galvanometer. Here you can see that this is the experimental arrangement of ballistic galvanometer. It consists of a copper coil and a mirror is attached to the suspension strip, and we have used a scale for this scale a lamp is attached. Okay, initially what happens? Let us suppose a current I flows through this copper coil in the presence of magnetic field. That is, this copper coil is placed between two magnets, that is north and south pole. These two magnets generates magnetic field B. In the presence of magnetic field, when current I flows through this copper coil experiences torque. Due to this torque, what happens? This copper coil rotates from its initial position. When this copper coil rotates from its initial position, it produces twist in the suspension strip, and this suspension will rotate from its initial position. Here, a lamp which is attached to this scale, from this lamp a light is incident on mirror. Initially what happens? When initially the light from lamp will incident on this mirror and this light will reflect on this scale. Initially, if there is no current in the coil, then the light which is reflected from mirror will incident on this point, that is at 0 point. At scale, at 0 point, this light will incident. Let us suppose when current I flows through this circuit, then this suspension strip will twist due to the presence of magnetic field when current flows through the circuit. Then this mirror will change its position. Then we observe that there is a deflection in scale. Here, when current I flows through the circuit, this light will incident on mirror. When light incident on a mirror, this mirror will change its position. Then the light which is reflected from this mirror will incident on this scale. Here, let us suppose when coil twists, when suspension strip gets twisted, this mirror, the light which is reflected from the mirror will change its direction, and this gives the deflection theta. Simple. Current sensitivity is the amount of deflection produced per unit current. Okay.